All right, so today we're going to learn about solving logarithms. So welcome to my class, everybody, and we're going to get this done. So today's goal is I can solve for x using logarithms. So that is our goal today. So we're going to be given some interesting situations. Like in example 1, we need to, step 1, we need to kind of isolate or make the base with its variable alone. So the base and variable exponent alone. That's what we need to do. So what that means is this -1 and this 5 need to come off because our base is right here with that power. So we need to get that alone. So I'm going to add 1 over, so I get 5e to the 2x is equal to 17, and then I divide off the 5. Okay, so we're going to get e to the 2x is equal to 17/5. Okay, and if you want to decimal that, that's fine. So now what we're going to do is step 2 is after it's alone, we're going to use a log or a ln or natural log. So this is an e. So let me just show you how this is going to work. So I'm going to erase this, give myself some more space. So I'm going to take the natural log of both sides. So I'm going to do ln and ln. All right? And what we're going to do is that's going to cause this to cancel. And what's left is over here. So we're going to get the calculator out in a minute. So I'm going to pull this up here, running out of room. So what's left on the left is 2x. And then we have the ln of 17 over 5. Then we're going to divide off the 2. So x is equal to this. Now that would give you a b if you could just get this value. If you want to solve it all the way out to a decimal, let's get a calculator out and get an a. Okay, so just getting the solving portion down like that, getting into here, I'm happy with. So let's do this. So we have 17, let's clear this out. We have the ln of 17 divided by 5. Let me show you what this looks like here in a minute. So there it is, 17 divided by 5. And then I'm going to divide that by 2. So we're going to divide that by 2. So that's going to be our answer. So it's going to be 0.62, I believe. No, 0.61. There was a rounding mistake. Sorry. There we go. Then we're going to check our answer. So step 3, we're going to check to see if this works. So we're going to put this in. So we're going to have 5e to the power of 2 and then times 0.61 minus 1. And we're going to see if we get this 16. So notice I took this here and I put it in for x over there. So I have my problem I started out with and it needs to equal 16. So let's see if it equals 16. So let's get our calculator back out. So I'm going to hit 5, second ln for the e, 2 times 0.61, close parenthesis, minus 1. Enter, and notice I get about 16, so this works. All right, so that is the right answer. Okay, so if you just write this out and then put a check mark next to it on your assignments or tests, that would work for me. All right, number 2, same thing here. We have 4s. So they are isolated, they are alone. So notice there's no extra numbers. We have a power with a base and it's by itself, a power with a base and it's by itself. And so now we're going to solve using logs. And so what we're going to use is we're going to use the log of 4 because these are 4s. So how it's going to look is we're going to do log of 4 to both sides, like that. And that's going to cancel this one and that one. And what's left is the powers equaling each other. And then we're going to solve. So I'm going to add 3x. So we get 5x minus 1 equals 4. And I'm going to add 1 to get 5x is equal to 5. And I divide this. So x equals 1. And then next we need to check this. So we're going to put the 1 back in. This one won't actually need a calculator to do. Because when we multiply these, so 2 times 1 is 2, minus 1 is 1. And then negative 3 times 1 is 1. negative 3 times 1 is negative 3, plus 4 is 1. So those are the same, so we checked our answers. Example 3, we have a 25 and a 5, but notice the bases and the powers are alone, so we're actually ready. We don't need to isolate anything. And we always do the log of the smallest number. That's what I like to do. Okay, so we're going to do the log of 5 to both sides because that's the smallest base. So we're going to do log 5 to both sides. That's going to cause those to cancel, so we're going to get 2x plus 1. And then we're going to solve this out. Okay, so x minus 2 is going to come down in parentheses. That's just going to come down. We're going to solve this. So log 5 to the 25. What is that? Well, if you don't know, put it in your calculator. Log 25 divided by log 5, and you're going to get 2. So the answer to this is going to go here in front to be distributed. So we're going to distribute now, so we get 2x minus 4 is equal to 2x plus 1. We're going to subtract 2x to both sides. They're going to cancel. And I'm left negative 4 is equal to 1. Is that true? No. So this has no solution. Okay? So some of them will end up like that. That's why we always want to check our work to see. Here there's no work to check because there's no solution. If this happened on a test or quiz, you'd need to show all work to show that there is no solution. All right, example 4, we have a logarithm now. Remember, this is an invisible 10, right, from our last lesson. And to get rid of a logarithm, we're going to use bases. And so this is going to be a little tricky. So this is a 10, so I'm going to put a 10 here, equals 10. So I have a base 10, so we're going to add these bases to both sides. Okay, so those are the base 10s we're adding because of this invisible 10. And then what's left is going to become an exponent. So notice, I'm going to highlight this in green. Notice that this becomes an exponent. Okay, notice that. So my original problem is now an exponent. And the bases we're going to compute. So this is going to cancel. So on the left side I'm left with x, that's left. And then 10 to the 5th power is 1, 2, 3, 4, 5 zeros. So 100,000. And that's our answer. And we can check our answer by plugging this in. So log 1, 2, and we can put that in the calculator and it equals 5, so we're good. Example 5, same thing. ln is a base e. Okay, so the invisible e. Okay, so we're going to put our e's in, and then what's here, again, what is here and here is going to become an exponent. So it's ln 2x plus 1, and then ln 4x minus 9. What's kind of neat about this is the e and the ln's are going to cancel on both of them, so we have 2x plus 1 is equal to 4x minus 9. And then we can solve. So we subtract 2x, and I'm going to add the 9 at the same time. So we're going to get 10 is equal to 2x, divide by 2, so we get 5 is equal to x. We need to check this, so let's go ahead and do this. We actually won't need a calculator. I'll show you why here in a sec. So 2 times 5 plus 1 is equal to ln of 4 times 5 minus 9. So let's see here. 2 times 5 is 10, 11. Okay, so this is ln 11. And then 4 times 5 is 20. 20 minus 9 is 11. They equal the same thing, so we're good. Okay, so that's how we're getting our A's. Now again, if you're just looking for a B, you don't need to check your work, or you could leave it pretty short here. So again, you don't need to check your work. Okay. Example 6, this is a base 3. So we're going to have base 3's when we solve this. And again, what is left, all this stuff, is going to become an exponent. So log 3, 4x minus 1. and then 2. So it's all an exponent. These are going to cancel. So we're left with 4x minus 1 is equal to 3 squared, which is 9. Then we're going to add 1. So we get 4x is equal to 10 and divide off the 4. So we get x is equal to 2.5. And then we need to check this. So log 3 of 4 times 2.5 minus 1. And that's supposed to equal 2. 4 times 2.5 is 10. 10 minus 1 is 9. How many 3's, what power of 3 gives 9? 2. That's right. So we're good. Finally, we're going to find an inverse. Inverse is what we did last time. So we're going to switch x and y around. So whenever we find an inverse, we're going to switch x and y around. And then we're going to solve. So to get rid of the log, we're going to use a base. Again, this is a base 3. So we're going to use a 3 and a 3. And this stuff is going to become a power. So x log 3, 7y. So these are going to cancel. So we get 3x is equal to 7y. Then we divide off the 7. So 3 to the power of x over 7 is equal to y. And those are inverses. Okay? Fun fact, okay? So if this was f of x is equal to log 3, 7x, then the inverse would be written as f to the negative 1 of x is equal to 3x over 7. So these are the same things. If you look at this and this, it's the same thing as what we're given. They just change f of x to y, but when we change an inverse to f of x, then it becomes a negative 1. So this right here in function notation means inverse. All right? So that's what's different about y's is they're the same, whether it's the same or inverse, they're identical, right? But on function notation, the inverse always has a negative 1 to let people know. That's why I like function notation better, because it tells us more information. So I know which one is the original function and the inverse with function notation because of the negative 1. And I believe we're done. So kind of a quick lesson. You can go back and watch it a few times, but we're just solving using logarithms. So it's the same concept when you learned how to solve when you're adding and subtracting and multiplying, dividing, but now we have bases and logarithms. So there's a lot of different, math techniques out there that we're going to continue to learn. Have a good day. Bye.